In today's video, we're going to be taking a look at section 9.3, exponential functions. Exponential function is a function in the form of f of x equals b, which is a constant, raised to the x power. So, and that's kind of where it differentiates. Before, we were used to maybe something like x to a number. This time, what we're seeing is that the variable is as the exponent. Really, the best way to graph these is to do a t-chart, because depending on the number, the exponent can do some things to it that make it increase significantly depending on the number. So what you're going to do is you're just going to create a t-chart. And what we're going to do is we're going to just start with 0. And what we're going to do is we're going to plug 0 into the function, and we'll just do a couple. We'll do 0, 1, 2. And right away, you'll be able to tell just how fast this goes up because it is exponential. So I'm going to plug 0 in for x. So you're going to have 4 to the 0 power. And anything to the 0 power is 1. And then I'm going to have 4 to the 1, which is 4. And then 4 squared, which is 16. Now, we could keep going. We could go to 3, which is 64. But you can see right away at 16, that's going to be off our graph already. Now, what we'll also do is we'll do a couple negatives to kind of see what happens there. So we'll have negative 1, and we'll do negative 2. Now, when we plug this in, we're going to get 4 to the negative 1. And if you remember exponents, we move it down to the denominator, 1 over 4 to the first, which is 1/4, and then 4 to the negative second, which is 1 over 4 squared, which is 1/16. And so you can see that, again, exponentially, it's getting smaller to a fraction. Now, if I kept going with this and did negative 3, you would get 1 over 64. You'll see that it keeps getting smaller, but it actually can never be 0. And we'll be talking about that in another section of why that can't be. But what we're just going to do is plot that from here. So we're going to start with 0, 1, 1, 4, 2, 16 would be kind of way up there. And then I'll do a couple negatives to get the idea, although it's going to be almost impossible to get it accurate. Negative 1, 1/4, and so on. And you can kind of see it kind of going down. And then you'll just connect. Now, the thing about this is it will never actually go past that 0 line. That kind of acts like an asymptote. But that red line will always kind of approach it and get infinitely smaller. All right, we're going to graph this next one, which is the function equaling 1/6 to the power x. Again, what we're going to do is just do a t-chart, start with 0 again, and start plugging in. 1/6 to the 0 power. Well, anything to the 0 power is going to be 1. If I do 1/6 to the first power, that's just going to be itself as 1/6. And if we do it squared, that you apply to the numerator and denominator, so it's 1 over 36. And if I do it with 3, you get 1 over 2/16. Now, this kind of has an adverse effect of what we saw in the last one. So what you'll see here is 0, 1, 1 and 1/6, and 2 and 1/36, and so on. It keeps infinitely getting smaller. 1 and 2/16 is definitely smaller than 1 and 36. So let's try going the opposite way. Let's add a negative 1 and a negative 2 in there. So if I have 1/6 to the negative second power, and I apply it, 1 to the negative second, 6 to the negative 6, because they're negative exponents, they're going to kind of flip. It's going to be 6 squared over 1 squared, which is 36. Oh, I have that in the wrong place. So if I had 1 6th and negative 1, it would be negative 1, sorry, it would be 1 to the negative first power and 6 to the negative first, which would be 6 over 1. So when I go to plot this, negative 2 would be way up off our graph at 36, and negative 1 would be at 6. So again, this point should be negative 1, 6. That point's negative 2, 36. And so if we connect those points and graph it, you'll see that it's coming from left to right, having the asymptote towards the positive numbers, versus in the last graph it had the opposite effect. It came from the right side down to the negative numbers. And that's because of the number of the base. The base in number 1 was positive and a constant, an integer, while number 2 is a fraction between 0 and 1. In our third example and our last example, we have the function f of x equals 2 to the x minus 1 power. Go ahead and make a t-chart, pause the video, and make your t-chart. Alright, now take a look at the t-chart on the right. Kind of compare the numbers. You have 0, half, 1, 1, 2, 2, 3, 4, and 4, 8, and finally negative 1, 1/4. Now, you'll notice that in the other graphs that we had, kind of the typical intercept was right at 1. It was 1 here. Well, you'll notice, though, when you start plotting these, is that your intercept will be shifted. So, or shifted downwards. 0, half, 1, 1, 2, 2, 3, 4, 4, 8, and if I go down, it's 1 and 1/4. So the intercept gets lower, and that typical 1 that was that intercept got shifted over to the right. So normally that intercept is right here at 0, 1, but you notice that the graph is kind of shifted right 1 unit. And the reason why that is because of the exponent being x minus 1. So it shifts the graph right. Now, as you can imagine, if the function would be fx equals 2 to the x plus 2, the graph would be shifted to the left 2 units. But we'll finish this up and kind of connect it, and you can kind of see what that exponential function looks like.